Good morning, Ed. I have the privilege to work with Ed when I served the ICE Council between 2013 and 2017. Ed has contributed a lot to the revamping of ICE in the last decade. Ed graduated from the Imperial College in 1989. During his 12 years with Binney and Partners, he obtained a master's degree in hydraulic engineering and worked on some 50 infrastructure projects all over the world. He joined Expedition Engineering in 2002, where he has been the project director for many projects, including the multi-award-winning Infinity Bridge at the Olympic 2012. He currently works on major projects and programs in the UK and internationally, and he focuses on strategic engineering design and improving productivity across the asset life cycle. He is a Royal Academy Visiting Professor of Innovation and a member of the UK's I3P Strategic Leadership Group, which is focused on innovating across the built environment. Ed has been actively involved in design education since 1999, and he is a Royal Academy of Engineering Visiting Professor of Innovation. Today, Ed will talk about a very interesting topic: improving productivity to fight climate change. Ed will also join our panel discussion later on. The audience are welcome to forward their questions, insights, etc. to Ed. Welcome, Mr. Ed McCANN, the ICE President.
Thank you very much, and good afternoon. Thank you particularly to Mr. Rupert Leung, Chairman of the Organising Committee of the ICE Hong Kong Annual Conference 2022, for inviting me to address your 2022 Annual Conference. I hope you've had a good conference so far, and the previous speakers have given you a good idea of where we are as an industry in Hong Kong when it comes to tackling climate change. I know that you heard from the Secretary for the Environment this morning, Mr. Wong Kam Sing, about the Hong Kong government's vision to achieve net zero 2050 with the Hong Kong Climate Action Plan 2050. At the ICE, we are fully behind this strategy and the government of Hong Kong to deliver that. As many of you know, the ICE has many members across the world. And in my discussion with engineers and politicians, it's very clear that the global engineering community has to ask itself what it can do on a global scale, working together to address this challenge. So I hope that you've enjoyed the speeches so far and that you're ready for one more now. Some of you may know that in November last year, I launched my presidential term with the theme of improving productivity across construction and infrastructure. And you may be wondering what productivity has to do with climate change. In my opinion, it has a huge amount, as I'll explain now. While my predecessor, Rachel Skinner, shaped her presidency around decarbonisation, I wanted to build on her work, focusing on things that our community of engineers can do, no matter our rank or responsibility, to help advance the cause. Productivity to some may sound like it's about output and increasing profits, but fundamentally, productivity is about effectiveness and efficiency. And in this sense, effectiveness means doing things that achieve the desired outcomes, including providing and improving resilience through the projects that we do, protecting both society and the natural environment from the effects of climate change. And efficiency means doing things without waste. And when I talk about waste, I'm talking about waste in human effort, in materials, in energy use, in land take, and so on. Less waste in a sector like infrastructure means less wasted resources from material overspecification, less energy used from unnecessary material transportation, and so on. And each of these results in reduced carbon emissions. So productivity, it's not just about saving money, it's about reducing carbon emissions and improving societal outcomes from our work. And that's why I've chosen to focus all my energy this year, bringing together global insight to demonstrate how increasing productivity in construction is key to addressing the challenge of tackling climate change. About 12 years ago, my colleague Chris Wise led an exercise exploring the issues of material overspecification in structures through the Enough is Enough project, and we funded engineering doctorate students to explore the problem in detail. This work has been developed and expanded through the Material Efficiency in Construction programme at Cambridge and Bath universities, and reveals how a combination of commercial drivers, risk aversion, and sometimes plain ignorance have resulted in endemic overspecification in the materials used in the structures that we build. How much? Well, typically you're talking about 30 to 50% too much material, and that material comes with carbon embedded in it, and so it's a huge issue. At home in the UK, through the Get It Right initiative, known as GERI, we've been exploring the cost and causes of avoidable error in construction. What we found was that wherever we looked, there was error. We concluded as a research group that between 10 and 25% of project costs were directly associated with avoidable error. The reasons for this are varied, some are very understandable, and some are frankly embarrassing. Material waste in construction is extremely high, with some 10 to 15% of materials by value brought to construction sites wasted. And it's particularly high in building projects, actually. Construction programs and schedules are suboptimal, typically 15% suboptimal. Work done in California has shown that over and over again. Average labour utilisation is also poor, typically in the range of 40 to 60%. Plant utilisation is poorly understood, but it's known to be very low compared to other sectors. All of these issues need to be resolved to reduce our carbon impacts, particularly if we're going to do that within reasonable time and financial constraints. A few years ago, I led a review into professional skills for the institution, and we were exploring the emerging skills needs for the civil engineering profession in the 21st century. This work revealed the critical issue and critical challenge of getting people with the right soft skills, which is a very unfortunate term because soft skills often turn out to be the hardest skills to acquire. It's vital that we encourage civil engineers to be more imaginative and more diligent in developing infrastructure that maximizes the benefit to our communities. And to do this, civil engineers need the soft skills necessary to engage with the communities that we serve and understand their needs. In other words, we need to start training engineers to look for the social value of projects and look for engineers who possess skills and abilities other than straight technical skills. These principles, by the way, are very well set out in Construction 2.0 and in the thinking of the Development Bureau. Empathy is a huge component of building resilient, sustainable societies everywhere. And perhaps we need to open up the sector to other professional backgrounds and make it easier to retrain as an engineer. In future, we will need to develop our skills in the use of techniques and technology to collect and manage data, to communicate more effectively, to design and plan optimally, and to manage our operations more effectively. In my view, effectiveness and efficiency within our sector are key to both reducing carbon emissions and addressing the already occurring impacts of climate change. And the benefit of improving efficiency will be to release the money, the human capital, and the other resources that we need to do more for our society, including renovating hospitals and schools, building houses, and undertaking projects to protect people from the adverse effects of climate change. I know it's easier said than done. The construction industry is a huge sector that can be slow to innovate. We need to learn from each other so that we can share global best practice. We can look at barriers in our business models at every stage of production. Regulatory barriers and risk aversion can be a huge obstacle to technological improvements. Some countries address these really well, and they can help others. There are also issues around a dysfunctional marketplace for technology, where solutions and choices need to be brought directly to the client, who often struggles to find what's needed at all or don't know about existing solutions. Moreover, current business models, based as most of them are on reward by the hour worked or by the ton of material used, usually mean that process failings or errors in process benefit consultants, contractors, suppliers. And these ineffective business models need to change to deliver improved end-to-end efficiency in our infrastructure delivery processes. Only once we've reformed our business models and refined our process can we really get the benefits of technology in enhancing outputs and increasing efficiency. And it's only when we revise those business models that we'll be able to engage the creative power of our people to properly address the challenges that we face. The bottom line is that all of us need to be more imaginative and more diligent in developing and operating infrastructure that maximizes the benefit to our communities. Wherever I go, I pick up the importance of really effective client organizations. Too often as an industry, we complain that our clients don't understand their desired outcomes. We need to help them to do so rather than just complain. As designers, we must produce designs that are lean, elegant, error-free, properly communicated and buildable. In procuring infrastructure, we have to consider social and economic value, not just capital cost. And we also need to accept that everyone involved has to make a reasonable profit. If all this sounds simple and doable, let's not forget a crucial reality. Climate change and its effects are here now. Geography makes Hong Kong vulnerable to climate change, as the frequency and intensity of storms, cyclones, droughts and heat waves are all going to increase. In the UK, we're also beginning to feel the effects of climate change through increased storm frequency and intensity. Last year, Storm Arwen caused dramatic devastation across our country and exposed the flaws of an infrastructure system that simply did not factor in resilience adequately. We're seeing now how the consequences of not building resilient enough infrastructure are devastating because they're felt for the long term. In terms of cost, for example, of repairs, also in terms of human lives and happiness, which is our absolute priority to protect as engineers. We all want to live in a safer, better environment. Some regions will be more affected than others, in particular by the risk of droughts and their effect on water supply. But if done right, adaptation to climate change can bring wider positive outcomes, such as improved livability, environmental protection, and economic prosperity. So fighting climate change is about much more than reaching net zero. It's about dealing with the changes in climate that are happening already. It's about intelligent adaptation right now. Poorly performing infrastructure ripples through absolutely everything that surrounds us, our environment, our health, and our quality of life. Governments around the world are waking up to this reality and can do more to help the private sector increase climate resilience. For example, by publicly disclosing climate risk assessments, forecasts, and design guidelines, or demonstrating best practice through adequate design and retrofit of public infrastructure and government buildings. Soon, there won't be a country left in the world that won't have to upgrade its networks, retrofit all types of existing infrastructure to protect its citizens. So there's a lot of work to be done. But I believe we're on the right track and that working as a global community, we can succeed and come out better and stronger as a result. So let's get on with it. Thank you very much.